Hello and welcome to Learn Data. I'm Nilesh, and in this video we'll continue to learn about time in pandas. Specifically, we'll look at what are pandas intervals. Then while coding, we'll look at how to shift the data and the time series in the index itself. We'll also look at how to change the frequency and how to resample a time series. We'll also look at what is a sparse time series and how we resample that. And finally, we'll end the video by looking at a comparison between a groupby and resample. So first, let's look at pandas intervals. Here, I've created this slide where let's assume that we have this data from numbers from 0 to 10. Now if we are trying to bin them or based on an interval which is, let's say, from 0 to 5 as shown here, the square brackets, what it means is that these endpoints are included within that range. So the range is from 0 to 5 including 0 and 5. So the output would be 0, 1, 2, 3, 4, 5. Now in the second case, where we have parentheses, it tells us that both the endpoints are not included. So the output would be 1, 2, 3, 4. So 0 and 5 are not included in this particular range. Then moving on, we have a square bracket on the right hand side, and therefore that is closed right. And here there is a parenthesis on left hand side, so that's open. And therefore, as we see here, the output would not include a 0, but it would include 5, and that's shown here. Similarly, if it's a square bracket on the left hand side, that's closed left, then the 0 endpoint would be included in the output, whereas the parenthesis on the right, so that's open, and therefore that 5 would not be included in the output, and therefore we have 0, 1, 2, 3, 4, and there's no 5 there. Now let's get into Jupyter Notebook and start coding. Here I've already created a new notebook and imported these three libraries: NumPy, Pandas, and datetime. I've also added this cell here to check the versions. For some reason, the notebook is running in 3.8, but when I look at the Python version by this method, I see 2.7. If you see something like this, please post them in the comments below. I'm trying to find a workaround why this is happening. So now let's get started with time series. First we'll look at what is shift, and we'll create a series to work with this. So a is equal to pd.series, and this would be a simple series with numbers 0, 1, 2, 3, and let's say 4, and we'll add an index here. So index is equal to, here I'm gonna add pd.date range, so date underscore range, and let's start at 2020 07 27, and the periods, so we need 5 data points, so we have 5 dates here. In frequency, I will put it by 1 day. Now when we look at the series, this is the series we have created. Now we can now try to shift the data points that are here 0, 1, 2, 3, 4, or we could shift the time series itself. So we'll try the data points 0, 1, 2, 3, 4 first. So a dot shift, and periods is equal to, if we shift by 1, then we are moving this row by 1 down. So 0 goes to the date 28th, and subsequently the 4 goes out of that particular data set. So we have one NN created here. Similar to this, we can also go ahead and add a -1. So a dot shift periods is equal to -1, and now we have, what we have is, we have moved the data up, we have moved the rows up, so the NN is in the last row for the date 31, because 4 was moved up to the position 3 for date 30th right here, and the 0 goes out of the series, so its place is taken by 1. Similar to this, we can increase the uh, amount by which we can shift the data. So let's try that. Here if we can type a dot shift, we could have the periods as 2, and what that will do, it'll move by two rows, and so we have 2 NANs there. Let's now look at how we can use time shift. So as we see that the series is a, which is this. Now here if we type a dot t shift, so time shift, periods is equal to 2, frequency is equal to 1 day. Now when we run this, we see that the 0 1 2 3 4, those data points are there as is. However, what has changed now is the time series index. Because we have a +1, all these time dates have moved by 1 day. So 27 is now 28, and so on and so forth. So 31st has now moved to the month of August, which is August 1st. Similar to +1, plus, we could add -1 here. So let's do that. So if we add a -1, then we would expect that the days would go back in time, so -1 day. So 27th now becomes 26, and 31st now becomes 30th. So that's how we can change the time in time series in the index and leave the data as is, which is 0 1 2 3 4. Now moving on, let's look at another way in which we can manipulate time series. So here we'll go ahead and create an index, pd.date_range, and again I'm going to use the same date, 2020-07-27, and periods is equal to 3, and frequency we'll use business day offset. So pd.offsets.bday, and n is equal to 2. So what we are going to do is we are going to use offset of 2 business days in this case, and we'll create a series. So if we want to look at the index, this is the index we have created. Now for series, we'll use pd.series, and for this 11 22 33, and for index we'll use the index we just created. And so the series that we now have has 3 data points, 11 22 33, with the index with dates that go from 27, we have 28 29 and 31st, so 3 dates. Here we can look at the frequency, we can change the frequency. So let's say we change this frequency by 1 business day. So a dot as frequency pd.offsets.b day, and here we change this frequency, n is equal to 1. Then what we have done is we have added business day. So if we look at the business day, a dot index, we look at 0, and if we look at the day underscore name, then we can see it's a Monday. So we have Monday, the Tuesday was missing, so we have Monday, Wednesday and Friday. So now we have Monday, Tuesday, Wednesday, Thursday and Friday. Also we added those missing days in there as NANs. Next, we can go ahead and pad these numbers which are NANs right here. So to do that, what we can do is I'm going to copy this and paste it right here. If we use 2 days, what we can do is, so okay, let's go back to 1 day. So here we have this. Now we can pad these values. So we can say method is equal to pad, and what that will do is it will put the numbers that are before it in this cartoon. So this NN was padded by the 11, this NN for day 30th was padded by 22, and that's what we see in the output here. Now let's look at resampling. For resampling, we'll go ahead and create a new series. A is equal to pd.series, and let's say 11, 22, 33, 44, 55, 66, 77, 88, 99. So that's the series we have. And for this, we'll also go ahead and create the index. So index is equal to pd.date underscore range, and we'll use the same date, 07 2020-07-27, and periods. So this time we have nine data points, so we have 9 there. And frequency, I'm gonna this time use seconds. And so this is the series that we have created here. And now what we are going to try to do is resample from this series using seconds. So resample 2 seconds, 3 seconds, etc. So let's try on that now. So a.resample, and if it within quotes, if you type 3s, and what this will give us is an object that we see here, and from this we can, this is similar to a group by object. Now from this we can get the min. So what we are doing here is we are telling Python to group these in 3 seconds. So the first set would be 00 seconds, 01, 02. So that's the first set. Minimum of that is 11, and therefore we have the 11 here in the output. Now the label, default label and default closed is left. So we have 0, 0 as the index for the seconds right here. And the second resamples set would be these 3 records, and here we have the minimum 44 that appears here, and then the time point corresponding with the left label is 03, and that's what we see here. Same thing for the last 3 records. We have 77, 88 and 99, and in there we have 77, which is the minimum. That's what we see here. And then we have 606, which is the left label that we see here in the output. Now we can check this. So if we look at a.resample 3 seconds, and if we say label is equal to left, and if we say closed is equal to left, closed is equal to left, in this case then we see that the output is similar as what we have below. So when we run this, we see that it's 00 seconds, 11, 03, 44 and 06, 77. So both are the same. Similar to close left and label left, there is another option which is right. So for that, what we would type is, I'm gonna copy this entire line here and just change this part. So label right, close right, and there is a difference here. So what happens in label right and closed right is we are looking at the right endpoint of the interval. Because this is a 3 second interval here, whenever we are saying right, this first row that is here, that becomes a separate group in itself. So instead of 3 as we had in the previous case, now we have 4. So for 11 we have 11 here, and the seconds is 00. That's what we have here. Then the second set would be these 3, and for these we have 22 minimum, and that's what we have here. And because we closed on the right, the label now is on the right label, which is 03. Similarly for 55, if we look at these 3, the minimum is 55 and the right label would be 06, and that's what we have here. And then for the last one, which is these two and the one that does not exist, which would be 0.9 second here, the minimum is 88 and that's what we have, and the 0.9 is after this, so 0.7 0.8 and then when there will be a 0.9 to make it 3 second interval, and that's the 0.9 that we see here. Now again here we'll look at couple more examples so that this becomes clear. What I want to show is max. So if we use max in this case, what we see is the time points now between the min and the max are the same, 0, 3, 0, 6, 0, 9 as we saw earlier, but now we are looking at the max. So let's check this. For the first row becomes its own group, so 11, that's the max we get here, and the label is right, so we get the 0, 0. Same thing then for the next one, the max for this is 44 and the label for that is 0.3, and that's what we see here. Similarly, the max for this is 77, the label is 0.6 seconds, and that's what we see. And for the last one, which is 88, 99, the max is 99 and the label that we see is 0.9 because that's the third second, so 0.7, 0.8 and then there is 0.9. So that's how we can use left and right. We can also use a combination of left and right for this. So let's say if we want to check a.resample, and now if we again use 3 seconds, but this time if we use the label of left, label is equal to left, and now we close it on right, so we have right as the close, and then again we are looking at max. Now what happens here is, sorry, closed is equal to right. Now in this case the 11, 44, 77, 19 and those numbers stay the same. What changes is the label that we have here in the index. Because this is label left, when we are looking at 11, this is the first one, the left endpoint for this one would be 3 seconds before midnight, 00. Therefore we have 00 minus 3, therefore we have 57, and that's what we see here as the 57. Then for this particular group, the minimum is the maximum is 44, and that's what we have here. But then the left endpoint for that group, which is not included because we are closing on right, therefore the left endpoint which is not included is the 00 endpoint, and that's what we have here. Similarly, now if we look at the last item, which is these two, and there are only two in this case, the max is 99 and the left endpoint, which would be the open endpoint because we are closing on the right in this case, is 06, and that's what we see here as 06. Okay, similar to this we can also go ahead and use label right. So if we can change the label to right, so right, and we can close this on the left, and again let's look at min in this case so that it makes it easier to understand the close on left. Now in this case we have 0 in, because we are closing on left, we have these 3 as the first group for resample 3 seconds, and the min of that is 11, and that's what we have here. However, because we are closing on right in this case, we are going to use the right endpoint, and the right endpoint would be open because we are closing on left, and this case the right endpoint therefore will be 03, and that's what we see here. Same thing for the second set, which is this one, the minimum is 44 and the right endpoint, which is the label, in this case would be 06, and that's what we see here in the output. Finally, for the last one, this is these are the 3 records, and here we have 77 as the minimum, and the right endpoint is 09, which is not here, so it would be below this, and because we said label right, therefore we have 09 here for 77. I know this is a little bit confusing, but if you try a couple of combinations on your side, I think you'll get an idea of it. If you still have questions, please let me know in the comments below. uh, there is another way we can adjust this again. So if we take this example, here we can specify L offset. So L offset is equal to, and we can specify seconds. Now because let's say we have 77 here and we want to get 06 as the time point near it instead of 09, then what I would do is type -3 seconds, and when we do that we move the time series index by 3 seconds. So now we can get the 06 for 77, 03 for 44, and 00 for 11. So that's how the label, closed, and L offset can be used in different combinations. Let's now move on to another topic. I hope I did not confuse you with this, but let me know in the comments below. It'll get more clear as I go through a few more examples on this. Let's now again try a.resample again 3s, and now if we try sum, so sorry, my spelling mistake. So when we try sum for this particular set, we have 33 plus 33 is 66, and then for this one we have 165, and then last three we have 264. There is also another option we can use. So a.resample again 3 seconds .ohlc, and what this does is it gives this data frame output where we have O for open, then high, low, and close. This could be useful in certain situations where you're, for example, if you're trying to analyze stock data, then open, close values for each of the stock values. You'll be able to see that using this particular command ohlc. Now let's look again at the closed left and right, how that works. So we know that this is the series we have here. If we type a.resample, this time if we use 2 seconds, closed is equal to, let's say, right, and we are going to again take max of this. Now because we closed right, as we saw before, the last data point is included. So for 2 seconds this will be 0, 1, and 2. The 2 would be included because we are closing on right, and therefore the output for this particular case would be a max of 33, as we see here. And while we are at it, if we look at the sum is 55, so only these two are included. We are not looking at 11, and just these two. Now let's go back to max, and the first data point 11 has because we are closing on right, the time is -2 seconds, so that is brought into the output. So we have 58 seconds there. Now again here, if we use left, what happens? So if we use copy this and we try left, what we would expect is we are closing on left, so this would be included in the output. So okay, here as we can see, so this particular date 00 midnight is in the output, and then the max of these two is 22 that we have here. And similarly, moving on, the max of these two would be right here 44. So that's how we can use close left or right when we are sampling data from a time series. We can also try to use another option which is sum and count. So let's try sum first. And while we are using the closed left or right, we can also change the label. So label is equal to let's say if we use right, we are closing on right and using the label right, and here if we do the sum, then what we can see is that for the very first data point we have 11, and we have a 2-second interval. Now because we have a label of right, we are using the right endpoint here in the output right here. So had we changed this to left, we have that 58, which would have been the label. So the sum, the first data point is as is 11, but then the sum goes from 22 plus 33, which is 55, that goes here, and then we have 44 plus 55, where we get 99. So that's how we can change the label on how we want the output to be after we perform a resample. Finally, I just want to show how count would work in this particular case. So if we use label, let's use label left and close left. So the sum in this case that we would get is, so we have 33 because we are closing on left, so left data point is included, so 11 is included, and so therefore we have 11 plus 22, which is 33, and we are closing on left, so therefore 0 0 0 is included in the output. Now if you look at the count, as we can see, because we are closing on left, we have 2 data points right here, and for the last one, because we are closing on left, this is 1 data point and there's nothing after that, therefore we get a count of 1 in the output. Now moving on, let's look at another additional parameter we can pass to resample. So as we know, this is the series we have been working with. Now we can pass loffset. So a.resample 2 seconds, and here if we say closed is equal to right, and loffset is equal to, let's say, 5 seconds. And now if we take a sum of this, so what this is going to do is in the output, because we have a offset of 5 seconds, this would become 0 5 0 6 0 6 7 8 9 and so on and so forth. Therefore for the very first data point, which is 11, this, because we are closing on right, here it will have 5 seconds minus 2 seconds, because we are sampling on 2 seconds right here, so therefore we get a 3 right here, and therefore we just have 11. For the next one, then we have these 2 data points, this is 0 6 0 7, and because we have the loffset of 5, and then we are getting a sum of that, so sum of this will be 55, and because we are closing on the right, the default label here still would be from the left. This will become more clear if we try another example. So let's go ahead and copy this and run this with left, or we can add a label. So if we add a label, label is equal to left, and now if you look at the output, this output and this output is the same, and that'll explain why in this particular row we have a label of 0 5. That's because we are using the default label. Had we changed this So if you are looking to use the label uh, on the endpoint where it is closed, then we have to specify that explicitly. So here what we can do is specify, let's say, closed left and label left. Then what we get is the left label. So this becomes 05, 06, 07, and because we are closing on left this time, we are going to be summing these two, and so we have 11 plus 22, 33, and then we have next, which is these two, where the seconds would be, this would be 5, 6, then this 7 and 8, and because we have label of left, we get 7, and we get a total of 33 plus 44, which is 77. So that's how the closing on left or right works. Now let's look at how upsampling works. So upsample, and we're going to use the same series that we have created earlier. Now for this one, let's first upsample by maybe 0.5 seconds. So a dot resample, and let's say we use 0.5 seconds, and dot as frequency. Now what we have done is we have added new data points in the series, where the in time series index has these additional time points of which are shifted by 0.5 seconds. So we have 0, and then we have 0.5, 1, and then we have 1.5. The values of those new time indices is NaN. So that's how we can upsample a data set. So we almost double the numbers that we had before. Now we can use any other combinations for upsampling. We could try milliseconds. So a dot resample, say how about 500 milliseconds, and dot as frequency, so we get the same result that we had before. Now the milliseconds can also be replaced by L, which is right as we used before. So if you type 500 L, we get the same output as before. Now as we have seen earlier, we can go ahead and also use a forward fill. We used pad earlier. We will now go ahead and try forward fill to replace these new NaNs that we have created by values that are above it. So we'll resample again with 500 milliseconds, and then we'll use dot ffill, so that's forward fill. And what that has done here is it has replaced the NaNs in the series by the values that were present before the NN. So we have these 11, which has taken the place of NN, which was earlier there. Sum. So if you type a dot resample and 500 milliseconds dot sum, now we get 11, 0. The reason why we get a 0 here is because the default for the resample is closed on left. So this is the same as saying a dot resample 500 milliseconds, and this is label on left, and then also closed on left dot sum. So as you can see, because we are closing on left, this is a 500 millisecond interval, and therefore this is the first data point we have, and so that's 11, there's only one data point at that interval, because we have this series which is zero point 0.5, and therefore we just have those values, and there's no data point at zero point 0.5 seconds, because it was NaN, and that's why we have this 0, and so on and so forth. We have 22 0, so all the NaNs become 0, and the values, there's only one value, so there's nothing to add to. If we get the count for this, as we can see, there's only one value, and therefore the sum is just that value in the output. Now let's go ahead and look at sparse. So for this, what we'll do is we'll go ahead and import a library, which is from function tools import partial, and then the next one is from pandas dot tseries dot frequencies dot import to underscore offset. So here we'll go ahead and create an index. So index is equal to pd dot date underscore range, and we'll use 2020-07-27 periods. And we have periods is equal to 100, and then we have frequency is equal to say 1 day, and then here we'll add time. So once we have this, so that's the date range we have, and then here we'll add a time delta of 1 second. Now if we look at the index, this is what we get. So we have 100 data points in here, which are varying by day, and then instead of 0 0 we have 1 second in the timestamp as well. We could, here what we could do is we could change the number of seconds, so we could also do that, or we could also reduce this number of periods. So we could reduce the number of periods to get just 10 data points right here. So this index can now be used to create a series. So pd.series, and here we'll use range length index. So we're going to create a series. So what length range index? So if you just look at the length index, that's just going to give us the length of the total number of items in there. Now if you put a range around it, we get numbers to all the numbers from there. So it's 0 to 10. So if you want to print them, so you could do print I, let's say for I in range print I. So we get all these 10 numbers printed out. So that's what the range is doing here. We're getting numbers 0 to 10, 0 to 9 in there. And then for index, we'll go ahead and use index is equal to index. So this is the series that we have created. Now we can use resample to get a sum of this. A dot resample. Here we are going to use an interval of 3 minutes and then get the sum. So as you can see, what we have here is all the records that are upsampled, and we have the sum of that. Earlier for the day 27, we had just one time point of 0.1 second. Now we have several time points which are separated by a 3 minute range. So we have 0 0, 0 3 minutes, 0 6 minutes, and so on and so forth. Now because these time points do not have any value, they are here as 0, and the sum is for each of those time points. So therefore the sum for those would be 0 because there's nothing there. However, if we look at a specific time point, for example 0 2 7 0 0, this is 0 because it was a 0. Now if we look at this time point, which is 0 0 0 28, let's look at that. So a, and here we specify the time point, and within the time point we specify, we remove this 0 1 and add 0 0 there, and then look at what's in that time point. We can see that, let's go back up, and I'm gonna have to save this. So let's go ahead and save this in a variable x, and then we print that x. Now when we look at x and add that value there, we can see that the sum value that was calculated at that particular time index is 1, and that's what we have here. Similarly, if we look at this time index, we should be able to see that that has the value of 8, and that's what we see here. So that's how upsampling works, and to create a sparse data set where even if there are no data points in there, we are adding new data points. So that's the beauty of using the sparse data set. Now let's move on and use a comparison with groupby. So when we try this, we are going to have to import libraries. So from function tools, import partial, that's one, and then the next one is from pandas.tseries.frequencies import to offset, and there's the second one. Here we'll create a function, df is equal to function, and that takes two arguments, frequency and x, and we'll calculate f as from the offset 2 underscore offset frequency, and then we are going to use temp. Temp is the variable where we'll store pd.timestamp. So this would be a rounded timestamp for the data frame, for the timestamp that we are going to get in. So we are going to divide it by nanoseconds, delta.value, and multiply again for the same value, delta value, and return the date out. Here if we use the groupby, a.groupby partial is the function we are using. Within it we supply this function we just created, and then we pass on the frequency, which is 3 minutes, and then we take a sum of this. So what this returns is the sum of the series that we have a, which is this. So the sum is the same because we just have one value for each of those time points for 3 minutes, and that's what we have here. However, one difference, as we can see here, is we do not get the rows, we do not get those rows back or indices back which were zeros. So this is kind of the consolidated version of this resampled sum that we had earlier, where we had around 4,000 items in that series, whereas here we just have these 10 items. That was it for this video. I hope in this video you all learned how to resample time series and how to use the label and closed arguments along with loffset to group the data and extract either the statistical information such as mean, max, or sum from the timestamps and the series. Also, we talked about how to use the shift, which is moving either the data within a series or using time shift to move the time indices and leaving the data as is. In next video, we'll continue to learn more about other nuances in working with time series data. If you have any questions, please let me know in the comments below. Please like, share, and subscribe. I hope to see you all in the next video. Thank you.